Hello, today we're going to look at the binomial distribution. The binomial distribution is a type of discrete distribution, and we need the following. One, we need to have a fixed number of trials, or a fixed number of events. There are two possible outcomes. There's a success and there's a failure. One doesn't typically denote something good and the other something bad, but rather the thing that we're interested in is called the success, and the thing that we're not interested in is called the failure. P is the probability of a success, and Q is the probability of a failure. Note that because there are only two possible outcomes, Q must be 1 minus P. And 3, the N trials, which are called Bernoulli trials, are independent. And then we're going to let the random variable x be the number of successes in those N trials. So for example, the number of heads in N coin tosses, the number of correct answers when guessing on a true-false test. When flipping a coin, there's only two possibilities, a head or a tails. And in our case, since x is the number of heads, head would be a success, and a tail would be a failure. Number of correct answers when guessing on a true-false test. Again, there are only two possibilities, true or false. True would be the success, false would be the failure in this case. For a binomial distribution, have the following. Mu, the expected value, the mean, is n times p, the number of trials times the probability of a success. And sigma, the standard deviation, is the square root of npq. So we have much nicer formulas than that long drawn out and general formula for mu and for sigma. We use the following notation to denote that the random variable x is a binomial distribution with n trials and a probability of a success p. We have that x is b of n comma p. So b for binomial, and again the first number is the number of trials, n. The second number, p, is the probability of a success. What we're interested in are finding the probabilities. So something like, what's the probability that x is a certain number? There is a mathematical formula, but we're not going to use it. It's a little complicated, and instead we're going to use Excel. So Excel has a really nice formula. It's already built in for binomials. So we're going to go over how to use that. There are typically three types of probabilities that we're interested in. The first one is the probability that there are exactly x successes. Mathematically, that's the probability that x equals x. And in Excel mode, this is equals. So remember, anytime you want Excel to do something, you have to use the word equals. So equals binom.dist of x n p0. So the x is the number of successes you're interested in, n the number of trials, p the probability of a success, and then the 0 is in the spot where it asks if you want it cumulative or not. So I just want exactly x, so I'm going to say no, not cumulative, so it's a 0 there. Another type is the probability that there are at most x successes. So mathematically that means the probability that x is less than or equal to x, right? At most 4 means 0, 1, 2, 3, or 4. So this is where it's the same thing everywhere, except my last number is now a 1 instead of a 0. And again, that's because that last spot is asking, is this cumulative? So cumulative means I'm going to add up the probability that x is 0, plus the probability that x is 1, plus the probability that x is 2, all the way up to whatever this number is here. So this is x less than or equal to x. I put a 1 in this last spot. And then the third type is the probability that there are at least x successes. So again, mathematically, this is the probability that x is greater than or equal to x. So notice the difference. At most x successes is less than or equal to. At least x successes is greater than or equal to. Any number that's at least 5 is 5, 6, 7, 8, any number that's bigger than or equal to 5. we're going to use the properties of probabilities, and we're going to rewrite this so that we have it in less than or equal to mode. So probability that x is greater than or equal to x is equal to 1 minus the probability that x is less than or equal to x minus 1. Okay, so remember that this is x minus 1 now. If I'm not bigger than or equal to, say, 5, then I'm either 0, 1, 2, 3, or 4, and it ends with 1 less than the number we started with. And this is because we're in a discrete case. There isn't anything like 4.5 or 4.8 or 4.6. So the next biggest number after, the next smallest number after 5 is 4. So you have to remember this x minus 1 here. And then I just plug that into my Excel by doing the same thing. 1 minus, and then here is the probability that x is less than or equal to x minus 1. So again, we've got the x minus 1 here. And you're going to see that come up in cases where our data set is discrete. Okay. So that's probably the biggest mistake that I see people making. They'll leave it as the x and not x minus 1. So we'll do a couple of examples. The first one says, there was a poll recently that showed 85% of U.S. adults know what Twitter is. Let's say we randomly select 8 U.S. adults. So the first thing we have to ask ourselves is this a binomial distribution? And the answer is yes. There are 2 choices. You either know what Twitter is or you don't. The probability of knowing it is the 85%. So the probability of a success is 0.85. And since we're randomly selecting them, they are independent. Just because Jane knows what Twitter is doesn't mean Bobby knows what Twitter is, because we're selecting them randomly. So we say yes, and again we're going to use this notation that x is binomially distributed with 8, 0.85. So 8 is our data set, our sample size. It's the number of trials, 8 people we're choosing, and the probability of a success is again 0.85. Question B, or part B, find the probability that exactly 5 of the adults know what Twitter is. So again, exactly 5 means the probability that x equals 5. And in Excel, it's binom.dist of 5, 8, 0.85, 0. And at this point, if you haven't already, you should really open up Excel and try doing these yourself. Make sure that you know how to type it in. So before I start giving you the answer, you should always pause it and plug it into Excel and then make sure that your answer matches what we have here. Okay, so again, if you haven't already, pause it right now and open up Excel and try typing in this first guy here. Okay, so hopefully you've done it, and hopefully you got 0.08386. It's not a very high percentage, and that's because, first of all, you're looking at exactly 5. That's usually smaller than if you're looking for at most 5 or at least 5. And then it already says that 85% of adults know what Twitter is, so it's more likely than not it's going to be more than 5 of the 8 people. But let's try C. Find the probability that at most 5 adults know what Twitter is. So again, mathematically, that's the probability that x is less than or equal to 5. Notice that that includes 5, so my answer should be more than my answer to part B. Right, the probability that at most 5 adults know what Twitter is means I'm going to be adding up the probability that no people know, that 1 person knows, that 2 people know, that 3 people know, that 4 people know, and that 5 people know. So we're going to be adding up 6 things. But again, we don't have to actually do that because there's a really nice Excel formula for it. And that is binom.dist of 5, 8, 0.85, 1. So remember that 1 means it's going to add up 0 through 5. And hopefully, again, you did it on Excel and you get 0.105213. Again, a number that's bigger than part B was. And then part D, find the probability that at least 5 adults know Twitter. So again, at least 5 adults means the probability that x is greater than or equal to 5. And again, that's 1 minus the probability that x is less than or equal to 4. At least 5 means 5, 6, 7, or 8, which means I'm not including 0, 1, 2, 3, or 4. So that's the part I'm subtracting from the 1. And again, that's just 1 minus binom.dist 4, 8, 0.85, 1. And we get a very large number, 0.978648. So it's a fairly high amount. It's a good probability that at least 5 of the 8 people know what Twitter is. And then we're also going to find mu and sigma. So mu, remember, is n times p, which in our case is 8 times 0.85, which is 6.8. Sigma is the square root of npq, which is the square root of 8 times 0.85 times 0.15. Remember, q is 1 minus p. And I get 1.00995. So again, you would expect to find that 6.8 people know what Twitter is. Now, obviously, you wouldn't say 6.8 people, but that's just the idea behind it. So you'd think there's probably a good chance that 7 out of the 8 know. Okay, and again, sigma is how spread out the numbers are. 1.00995 is not that spread out. But again, there's only 8 people to look at anyway. So let's try another one. Approximately 70% of students hand in their homework on time. Assuming each student does their homework independently, which is a very big assumption, but we're going to assume it so that we can use a binomial. We're also assuming there are 30 students in the class. Find the following, where x equals the number of students who hand in their homework on time. Probability that x equals 15. So again, we should just consider some things before we start going on. Is this a binomial distribution? Are there 2 choices? Yes, either they hand their homework in on time or they don't. Again, we're going to assume each student does their homework independently. The probability of a success is 0.7, and n is 30 in this case. So to find the probability that x equals 15, we want binom.dist of 15, 30, 0.70. And then again, don't forget that in Excel you need to have that equal sign before it in order for Excel to know that they're supposed to do something. And we get 0.010567. So again, it's a fairly small percentage. You're looking for exactly 15 out of 30, so exactly half, when you know that it should be closer to 70 if you're just, kind of guessing. So it's a fairly small amount. P, the probability that x is greater than or equal to 20. So the probability that at least 20 students hand their homework in on time. So with greater than or equal to, I need to rewrite it because the Excel commands are for equals or is less than or equal to. So to get greater than or equal to, I need to do 1 minus binom.dist of 19. So remember, this has to be x minus 1. So 20 minus 1 is 19. So 1 minus binom.dist of 19, 30, 0.7, 1. Again, that 1 is the cumulative. And that is 0.73073. And then the probability that x is less than or equal to 25. So the probability that at most 25 students hand their homework in on time. It's already less than or equal to, so that's binom.dist 25, 30, 0.71. And we get 0.969845, so a fairly large percentage. But again, hopefully that isn't too much of a stretch, because you would think that 0 to 25 students would definitely hand their homework in on time. So let's try another one. So what is the probability that x is between 22 and 27? So this is a little different than the ones that we've seen. And we have to figure out how to write this in Excel. So remember, Excel uses either the probability that x is equal to a number or the probability that x is less than or equal to a number. So if I want between 22 and 27, remember, I'm looking at 0 to 30, and I'm interested in 22 to 27. So I could use 0 to 27. Right? That is one of the things I can do in Excel, less than or equal to 27. But then I want to get rid of this section here. So I want to get rid of 0 to 22. And again, that I can write as the probability that x is less than or equal to 22. So I can rewrite this using less than or equal to. And it's the probability that x is less than or equal to 27 minus the probability that x is less than or equal to 21. Plugging those into Excel looks like the following. Binom.dist 2730.71 minus binom.dist 2130.71. So remember, this has to be x minus 1. I don't want to get rid of the 22 because x can be equal to 22. So I only want to get rid of 0 to 21. And if I plug that into the calculator, I get 0.429405. Okay, so again, I'm going to do it one more time because this is probably where most people get confused. I'll even put in the 21 here. This is what I want. So I can do this whole thing, which is this guy, minus this down here. And remember that there is no actual number here. There's nothing there. So we don't need to worry about what's in the yellow. There is nothing between 21 and 22. Okay, so the last part for this question, part E, again, we'll find mu and sigma. So mu is n times p, which is 30 times 0.7, so 21. We would expect 21 students to hand their homework in on time. And then sigma is the square root of npq. So again, n is 30, p is 0.7, which makes q 0.3, and we get 2.51. So as our last example, suppose you flip a fair standard coin 20 times and let x equal the number of heads. Is this considered a binomial distribution? So again, there are two possible outcomes, either heads or tails. We'll assume nothing funky like it landing on its side. There are 20 trials, and do we know the probability of a success? And the success in this case is the number of heads. And yes, we do. We know that p is 0.5. There's a 50-50 chance of flipping a head versus a tail, and that's because this is a fair standard coin. So x is binomially distributed with 20, 0.5. So part B, find the probability that x equals 10. So remember, equals, we have the 0 at the end of our binomial formula. And we should get 0.176197. What's the probability that x is greater than or equal to 6? So again, greater than or equal to, I need to change that to 1 minus the probability that x is less than or equal to 5. Right, so again, 1 minus, the original number minus 1. And in Excel formula, it looks like this. Plugging it in, we get 0.979305. And then lastly, the probability that x is less than 12. Notice this is less than 12, not less than or equal to 12. So if I'm less than 12, and again, I'm in something that is discrete, that's the same as less than or equal to 11. So you got to be careful, make sure you're reading it correctly. Strictly less than 12 in a discrete case is equal to less than or equal to 11. So when I put it into the binomial formula, I need to make sure that I have 11 here. And then I plug it in, and I get 0.748278. Okay, so read over the section in the book, try out some of the homework, and let me know if you have any questions. Good luck.